All right, we're going live here on Facebook for our event, How to Make a Golden Coin at Home Using Science. It's my first time doing a Facebook event, so I'm kind of excited but nervous at the same time. Hoping you'll have a chance to join us here. I know I've gotten a lot of inquiries about how to get into the live class and the live broadcast, and hopefully we'll have some people joining us here shortly. So in this experiment, I'll be using electrolysis to coat copper onto a quarter. Now this process is called electroplating. It's a process of using an electrical current to free ions from a base metal and move them to an opposing node. I'll be using a small piece of copper tubing as the base metal, though a penny or any other copper item might work. And the opposing node for this experiment will be the quarter. But you could do the same thing with a key or a paper clip or really any material that conducts electricity. Let me show you the materials that we will be using for this experiment. I've got a glass beaker, chosen a rather large one so it'll be easy for us to see the experiment as it goes. We'll be using vinegar, a vinegar solution to help speed up the process. You can actually do this with just a regular water solution, or some people, in order to speed up the process, will actually dissolve copper sulfate in water, and that gives it a blue tint. The blue tint is the copper dissolved in the water. We'll also be using for our source of electricity today a 9-volt battery. And in order to access that, a pair of wires that have an alligator clip on it. That'll give us a good grab. We need a piece of copper, and for this experiment I've chosen a little copper elbow, pretty inexpensive to pick up at the hardware store. And then of course, as I mentioned, our goal here is to turn our coin golden, and for this experiment we'll be using a quarter. So let's go ahead and get started on this experiment. I'm going to move my camera over so it's going to focus down on my desk surface here, and that will allow us to be able to see the experiment. Pardon me for just a moment while I move my camera here. Kind of pull this over and slide it up. All right, now that's not a very good image here, but we're going to focus this in, give you a little bit better light. And one last thing, zoom it out. All right, now we can see the work surface pretty well. All right, so we're going to get started by taking our vinegar solution, and I'm going to go ahead and pour it on into our beaker. Set my glassware aside. I'm going to take one of my wires, and you might notice I've got these little clips that I've put on the edge of it. That's going to allow me to secure it to the side of the container. I'm doing that because we don't want to let our two nodes touch in this experiment. So I'm going to take one of my wires and I'm going to clip it to the copper tubing. I can put that down into my solution. And the other side of the wire then gets clipped onto the positive side of our 9-volt battery. This is where those alligator clips come in use. I've seen people do this experiment before where they've used a standard size battery, like a AAA or a AA or a D, and then tape the wire onto the battery, and certainly that works as well. All right, so we've got our copper tubing set up. The second wire then, I'm going to attach this to the quarter, and we'll place this into the beaker Again, I want to secure this so that it doesn't have the ability to touch my copper tubing. So I'm going to kind of make myself a little looped it through one of the sides on the clip there. That just holds it suspended. My copper tubing and my quarter are about a ½ an inch apart from each other. We want to force the flow of electricity through the solution. We don't want to allow it to go directly from the copper tubing and into the quarter. All right, then I'm going to attach the second wire onto the negative side of our battery. Within a few seconds, we should see the reaction begin. We'll see bubbles forming on the edge of our quarter. If I pull this up here, you can see pretty quickly there's some bubbles going around on the edge here. And we want to let this just work a little bit. It takes some time for the copper to begin to dissolve the copper ions, and then for them to move through the solution and onto the surface of the quarter. I'm going to go ahead and set that down. So in just a few minutes time, a dark dusting will cover over the quarter. At that point, the bubbles will be flowing rapidly from the solution, and the whole solution will take a blue tint similar to the one where we saw copper sulfate had already been dissolved in. So here's the science of what's going on. A process called oxidation is freeing the copper ions from the copper tubing. The steady stream of electricity breaks the copper ions off, and those copper ions have the freedom to float around inside the solution, the vinegar solution. An interesting thing happens though when you are in oppositely charged. The opposite charges are going to attract each other, and so what we have when we complete the circuit, the electricity wants to flow through the completed circuit, and in essence what they do is they'll pull that copper ion over to the other node. Of course, the copper ion can't go through the wire the way electricity does. It doesn't travel up and into my battery, but instead they will just attach themselves to the outside surface of the quarter that's there. That's actually what we call plating. And it's a useful process in a variety of ways. One major way is that it allows manufacturers to save money and resources. They get to use cheap metals for the base of the product, and they place just a thin coating of a more expensive metal on the outside. As a matter of fact, since about 1982, the United States has been doing that for their pennies. We use a cheap metal called zinc on the inside, and then we plate it on the outside. Only the outside of modern pennies are copper. And so, you know, this is a copper penny. We're pretty used to seeing what this looks like. Get this up to where the picture, the light isn't quite such a glare. But I have another experiment that my students do where we hollow out a penny using an acid. And what I have left here, I've actually dissolved the zinc away. And this is one side. It's a little corroded from the chemical reaction, but you can still pretty well tell that's a copper. This is 1/2 of a penny. The other half over here, I've got a little tray where my other half is. Here's the other half of the penny. Now this side's a lot cleaner. Not shiny like a shiny new penny, pretty dull after the chemical reaction, but you can see how paper thin, literally paper thin, the copper is from the penny. Well, so it's a nice thing to be able to do, since if you were to make pennies out of the amount of copper needed for this same size coin, it would actually cost more than the penny is worth. So the United States decided they would keep making pennies, but find a cheaper way to do it. Zinc on the inside, copper plating on the outside was the solution. Now, plating is also commonly used with jewelry. So we can make it look pretty with silver or gold on the outside, but something inexpensive and sturdy on the inside. Or if you went to your pantry and take out some canned goods, It's probably a can made out of steel with a tin plating. The tin plating on the inside keeps the steel from corroding, which the natural acidity of the canned food would eat away at that tin or at that steel over time. Another example, plating allowed car manufacturers to create a strong bumper that would be bright and shiny. You remember days gone by, cars had a lot of chrome on them. Well, the chrome was actually chromium metal plated over the top of a steel base. And more recently, scientists have found ways that they can plate metal onto plastics, providing lightweight, cheap alternatives for use in plumbing, electronics, and many decorative uses as well. You probably even have some plated metal in your home. If not from one of the sources I've already mentioned, then probably in your silverware drawer in your kitchen. Few of us use silver anymore, except maybe on a special occasion. But the cutlery you have in your silverware drawer is often called stainless steel. And what they do is they take steel and they plate it, again, with chromium in order to protect it from rust or corrosion. I was actually preparing for this presentation and reading up a little bit on other uses for plating, and I learned that NASA used plating for equipping the astronauts' helmets when they would do a spacewalk. Back in the 1960s, the visor of the astronauts' helmets had a gold plating on it in order to protect the astronauts' eyes from solar radiation when they would be out of the spaceship conducting a spacewalk. Well, so there's lots of uses for plating. It's a pretty interesting process. And, you know, our plating is going on over here. Might not be quite ready yet. I can see there's quite a bit of bubbles forming here. Not as many as I'd like to see. But I want to show you the samples that I did earlier this week as I was preparing this. We'll take a look at our quarter here in a few moments, but it'll give us a little bit more time to let it work. So here's a quarter. If I can hold this kind of up to the camera, it takes a moment for it to get a good focus. Now you might not be able to tell the coloring on this quarter. It has a dull kind of bronze. It's not a shiny gold at all, but it's that gold or a dull bronze setting to it. Here's a quarter where I placed only half of the quarter inside the solution. So actually in this experiment suspended the quarter, and you can see very clearly the line between the side that was plated and the side that is the natural, normal, more silver color that we're used to seeing on a quarter. It becomes much more apparent too when you hold it next to a shiny quarter, and then you look at the plating that was, or the other one that I had before that I used earlier today. Compare the coloring of the quarters. Now you can actually do some variations of the experiment that are kind of fun. You can try different types of metal. Instead of using a quarter, you could make yourself some fancy golden colored or bronze colored paper clips. All you would do is clip them onto your wire instead of your quarter, and you would end up having bronze colored paper clips. So that's kind of a fun extension of this experiment. Or another alternative, you have to be careful with this one, is to increase the amount of electricity, basically increasing the flow, and so it increases the speed. I've found you actually don't get as good of plating, but you get a much quicker reaction. So for just kind of a moment here, I'm going to show you how this is done. You can take, if you're using 9-volt batteries, you maybe are already aware 9 volts have these specially shaped tops on them that ensures that you know which side's the positive and the negative. Well, they also allow them to connect into each other. And so you can take 2 batteries and connect them together. You've still got a positive and a negative. And I'm going to actually make a quick switch here. I'm going to take my negative and my positive off my single battery and put them on my pair of batteries here. We'll set that here. my copper got a little further away from, I moved this around when I was picking it up towards the camera, got a little further away from the coin than I prefer to have it, so I wanted to move it back there. Like I said, you do want to be careful. You don't want to let the two nodes touch. We want the electricity to have to flow through the solution. Now, when I combined my batteries there so that I had more flow going through of the electricity, it quickens the process a little bit, but it also doesn't give quite as good of a seal. I've actually found you get a better seal of the copper plating if you use lower voltage rather than higher voltage. So if you're interested in trying this at home, you want to try some different techniques. You could try some different metals. You could try using one battery or two batteries. I wouldn't go any more than that. Getting more than that, you can actually run into some heat issues, and we don't really want to invite any problems in our experiment. Or you could even use the tape method and try it with a AA battery. You've still got your plus and your minus easily identified. Rather than using wires with clips, you could use bare wires and then just tape them on the ends, and that should work just as fine as well. I also wanted to show you a copper elbow. This is the elbow I've been using this week as I've been working on this experiment, and if you just compare it to the one in the water, you can see the one inside my current solution is very shiny, but this one has this dull color on it. This is a result of the oxidation. Now, you maybe know some other examples of oxidation. Rust is the result of oxidation on steel, or the tarnish that you get if you have copper plating, maybe copper cups, or some kind of a decorative piece of copper in your home. You maybe clean periodically, and you get this tarnish on it just from regular interaction with air, but it's accelerated when you work in a chemical experiment like this. And if I do enough reactions with this elbow here, it will look like this as well. When I started, this piece of elbow was nice and shiny, just like the other one was. All right, well, let's go ahead and take off our electricity and take a look at our coin and see whether or not we've had it in there long enough to get some plating. I'm going to take the quarter and just take a little tissue I had sitting here and dry it off a little bit just to get the excess dust off of it. And then if I hold this up, now you got to remember we weren't in here for very long, so we don't have a tremendous amount of copper buildup. Nothing like on the samples that I showed you where we had this copper coin here, this quarter here, I had in the solution for probably about 15 minutes. And I think we haven't quite had ours in that long yet. And if I show you this one here, can't quite get a good angle with light and the camera. I can see just a little bit of copper coming up on the top of this one. And again, it might be easiest to see if we hold it up next to a shiny quarter, so you can see. Let's see if we can get a focused image on that. So almost too shiny, my light reflects off of it. Well, if you let it keep going, you can give it a half an hour, you could give it an hour, you could give it quite a long while. It's not a dangerous experiment that's going on. Leave it, take a phone call, eat dinner, come back to it. I'm going to move my camera here back to the normal place. All right, well, this is just one experiment that students will be doing in my pre-chemistry class, exposing them to the scientific process, allowing them to experience in a direct way several of the concepts that are taught in the course, and also providing them with practice on writing quality lab reports. So thanks for watching my experiment tonight. I hope it taught you something new, maybe piqued your interest in chemistry. And I also want to give you a time to ask questions if you have it about the experiment, maybe about my pre-chemistry class or any of the other classes that I teach at MyFunScience. So thanks again for being here, and I'll hang out for a few moments. If you've got any questions, feel free to send them in. I think I'll be able to view them on the chat, and hope you have a great night. If you want to find out more about the classes I offer, you can do that at MyFunScience.com, and you can look for teachers there. We've got lots of great courses. All of our courses are STEM courses: science, technology, engineering, and math. Hope you'll be able to join us, and look forward to serving you and your family as we get into a new school semester next January. All right, I see a question coming in on the chat asking about my favorite item to plate. To be honest, I actually really like the quarter as a plated item because it's just fun. It's unexpected. People don't think about having quarters that color, and so it often will catch their eye and stands out a little bit. And for that, I think if you saw something else that was kind of bronze, golden colored, you wouldn't necessarily be all that impressed with it. Yep, you sure can. Now the coin that we did today, let me see if I can get it here again. I gotta find which one it was. I got too many quarters down here. 1, 2, 3. See if I can identify which one of my coins it was. Not this one, not this one. I can show you one that's got the plating really pretty good. I don't know if the lighting is such that the camera will pick up on it. The problem a little bit becomes the glare. So on this one, there is a kind of a duller copper on this side. Again, it's a lot easier to see in real life, or if I show you one that's been in the solution a lot longer. This one here, and then if you hold it up and compare it to a regular quarter, it gets to be a lot easier to see. Now, in some regards, on the camera, it just looks kind of dirty. So you know what? Don't take my word for it. Do the experiment. See what it comes out like for yours. All right, I got a question. It says, what ages is the class for? Pre-chemistry is targeted towards a junior high or middle school age. So generally speaking, we're thinking about 7th and 8th grade students. I've had freshmen in there. I've even had some older students who weren't ready for higher level chemistry. They didn't have the math to do a higher level high school chemistry class, and so they took the pre-chemistry course instead. I've had students down as 6th grade students take it, and as long as they're mature enough to handle the classroom environment, the workload is usually easy enough for them to handle. It's conceptual based chemistry. We don't really do anything math oriented until the very last week of instruction, and it's pretty easy math of dealing with some ratios. Thanks for your questions. Hang out here for just a moment to see if there's anybody else. Appreciate the questions and the interaction. Thanks again for being here. You can continue to ask questions if you want. You're welcome to send me an email. I'll put that down in the chat as well. It's cleingang@MyFunScience.com. If you've got questions about the experiment or questions about the class, I'd love to hear from you. Yeah, a special needs student, it might be a good fit. We maybe want to talk more about what their experience has been and what their special needs, the specifics. Of course, we could do that in a more private way through email, or be happy to share with you a phone number. You could give me a call and we could talk about that as well. All right, we're going to go ahead and sign off then. Thanks again, everybody, for being here tonight. Email me if you've got additional questions. Watch for that coupon that is going to be going out to all of you who are attending the live class. All right, I see another question sneaking in here at the end. I'm happy to answer that one too. How to know if your student's ready for the class? Readiness is always an interesting question because students are so varied. This is a very low level of math, And so a lot of times it has to do with more with kind of their maturity than it does with their educational abilities. This class doesn't really expect anything in terms of prior knowledge coming in. There are no prerequisites for your student to have coming into the class. We start from zero and we build from there. The class is designed to be very repetitive in its instruction style. So every week we are reviewing the concepts that we did before and moving a little bit further down the road, if you will, as we go. Each week we're adding something new to our understanding, and each week the concepts will build one on top of the other. So they're immediately using the concepts that they've learned before, but we don't expect them to have any kind of knowledge coming in. It's really just a matter of being able to attend a 90-minute class session, being able to handle the responsibilities of the assignments that are given, safety in the labware, in the class, in the lab assignments, and of course, as you as a homeschooling family have the ability to provide as much supervision as you feel is needed as well. So you might have a student that requires you to be a little more hands-on. That's available to you and a possibility for you as well. So if you want to ask more, you want to talk more about specifics of your student, I'd be happy to talk about it. My email was posted in the chat there, so feel free to write that down, or you can find it at our website, MyFunScience.com, and would love to talk with you more as well. Thanks again for being here tonight, everybody. I'm signing off. Have a good evening. God bless.